Namaste. Welcome to the lecture session on elements of mechanical engineering. I am Anil Kumar MM, working as assistant professor in the Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. In the previous video, I was discussed about the machine tools, introduction to the lathe and parts of the lathe machine and specification of the lathe machine. Okay. In the today's session, I am going to discuss about the lathe operations. What are all the operations can be performed on the lathe machine? Okay. Lathe, all of you know the lathe. Lathe is a turning machine. It is generally employed for producing the circular shaped object, that is called as a lathe. And you can say that lathe is a versatile machine and it is the mother of all the machine tools. Almost all the basic operations can be performed on the lathe machine. Okay. So in that lathe, what are all the operations can be performed? Okay. So in the lathe, almost all the basic operations can be performed on the lathe machine. Some of the operations are, one is we can perform turning operation, we can perform facing operation, we can perform drilling operation, we can perform thread cutting operation, we can perform taper turning operation, we can perform knurling operation. Okay, these are all the operations can be performed on the lathe machine. Okay, now discuss one by one. Okay, first operation can be performed on the lathe is one is turning. I already said that lathe is a turning machine. Okay, what do you mean by turning? Turning is a lathe operation. It is one of the lathe operation. It is generally used to produce the cylindrical surface on the workpiece material. Okay, so turning means it is used to produce the cylindrical surface on the workpiece. We can call it as the turning. Okay, how we are doing the turning operation? Okay, while doing turning operation, first the workpiece, this is the workpiece material and this is the single point cutting tool. The workpiece will be rigidly held between the two centers of the lathe. The one center, the headstock center, we can call it as the live center, and the tailstock center we can call it as the dead center. So the workpiece is held between the two centers and this will be rotating at the high speed because the chuck will be connected to the spindle will be rotating at the very high speed, and the cutting tool will be rigidly held on the tool post or tool holding devices. Okay, while machining, first we have to feed the cutting tool against the rotating workpiece material. First we have to feed perpendicular to the lathe axis and then we have to move the cutting tool parallel to the lathe axis. Okay, first you have to feed the cutting tool against the rotating workpiece material and then move parallel to the lathe axis. At that time, the excess metal will be removed in the form of fine chips and to get the desired shape in the workpiece. That operation we can call it as the turning operation. Okay, while doing turning, first you have to feed the cutting tool against the rotating workpiece material and then move parallel to the lathe axis. So the sharp cutting edge of the cutting tool, when it touches with the workpiece material, at that time the excess metal will be removed in the form of fine chips and to get the desired diameter in the workpiece material. Generally, the turning operation, it is used to reduce the diameter of the workpiece material. In order to reduce the diameter, initially the diameter is around 20 mm, we have to reduce it to 18 mm. So we have to remove the 2 mm of material from the workpiece. So in order to reduce the 2 mm, you go for the turning operation. Just you have to move the cutting tool perpendicular to the lathe axis and then you have to move parallel. At that time the 2 mm metal will be removed in the form of fine chips and to get the desired diameter in the workpiece. That operation we can call it as the turning operation. Basically the turning operation, it is used to reduce the diameter of the workpiece material. Here the cutting tool can be moved parallel to the lathe axis. Next operation can be performed on the lathe is the facing operation. So what do you mean by facing? Facing is one of the lathe operation that is used to produce the flat surface at the end of the workpiece. We can produce the flat surface at the end of the workpiece material. That operation we can call it as the facing operation. How you are performing the facing operation? While during facing operation, the workpiece is the one end. This is the one end. The one end of the workpiece is rigidly held on the chuck and another end will be free because here we need to produce the flat surface, this end. So the one end of the workpiece is rigidly held on the chuck and the another end will be free. Okay, and the cutting tool is rigidly held on the tool post. Okay, while during machining the workpiece will be rotating at the very high speed, and the cutting tool can be moved perpendicular to the lathe axis. The cutting tool is moved perpendicular to the lathe axis. At that time, the excess metal will be removed in the form of fine chips, and the desired flat surface will be formed on the cylindrical workpiece. That operation we can call it as the facing operation. During facing operation, we are moving the cutting tool perpendicular to the lathe axis. While turning, we are moving the cutting tool parallel to the lathe axis. At that time, the diameter will be reduced, but while facing operation, we are moving the cutting tool perpendicular to the lathe axis. At that time, the excess metal will be removed in the form of fine chips to get the flat surface on the workpiece. Okay, generally the facing operation, it is used to perform reducing the length of the workpiece material. In order to reduce the length, we are performing the facing operation. In order to reducing the diameter of the workpiece material, we are using the turning operation. Okay, I hope all of you understood. The turning, it is the machining operation. It is used to produce the cylindrical surface. Okay, this operation, it is used to reducing the diameter. Here we are moving the cutting tool. First we have to fed the cutting tool against the rotating workpiece material, and then move parallel to the lathe axis. At that time, the excess metal will be removed and we will get the desired diameter. In order to reduce the diameter, we can perform turning operation. Facing operation, we are moving the cutting tool against the rotating workpiece material and move perpendicular to the lathe axis. At that time, the flat surface will be generated. Okay, this process, it is used to reduce the length of the workpiece material. Okay, next operation can be performed on the lathe is one is knurling operation. Okay, what I mean by knurling? Knurling is a machining operation. It is used to produce the serrated surface or the rough surface or the diamond shaped pattern on the cylindrical workpiece material. Okay, you can see here there is a diamond shaped, the rough surface will be generated on the workpiece material. This operation we can call it as the knurling operation. Okay, knurling is a machining operation. It is used to produce the rough surface or the diamond shaped pattern or serrated surface produced on the workpiece material. That operation we can call it as the knurling operation. This knurling operation is basically carried out with the help of a special tool that is called as the knurling tool. Okay, this is the knurling tool. By using this knurling tool, we can produce rough surface on the cylindrical workpiece material. Okay, now how to perform the knurling operation? While doing the knurling operation, the workpiece will be rigidly held between the two centers. Okay, here this is a workpiece material. The workpiece will be held between the two centers. One is the live center and another one is the dead center. And the knurling tool rigidly held on the tool post. Okay, this is the knurling tool rigidly held on the tool post. Generally, the knurling tool, it consists of the two roller. You can see here this is the roller 1 and this is the roller 2. It consists of two roller. At the surface of the roller, we can see that there is a pattern. Okay, there is a straight lines or the diamond shaped pattern can be visible on the surface of the roller. Okay, so when you feed the knurling tool against the workpiece material, the same shaped impression it will be generated on the workpiece. Okay, when you feed the knurling tool against the workpiece material, the same surface, the same pattern will be generated on the workpiece material. That operation we can call it as the knurling operation. Generally, this rough surface, it is used for the gripping purpose. Okay, if you have a rough surface, you can rigidly held. Okay, so if you have the fine finish, sometimes it may get slip. Okay, so for gripping purpose, this rough surface will be generated on the workpiece material. That operation we can call it as the knurling operation. Knurling is a machining operation used to produce the rough surface or serrated surface or the diamond shaped pattern on the cylindrical workpiece material. That operation we can call it as the knurling operation. This operation carried out with the help of a special tool that is called as knurling tool. Knurling tool, it consists of the two rollers. There is upper roller and lower roller. The pattern will be made on the surface of this roller. When you feed against the rotating workpiece material, the same impression will be formed on the cylindrical workpiece. That operation we can call it as the knurling operation. Okay, this operation it is used for the gripping purpose. This the rough surface is used for the gripping purpose. That is one of the operation can be performed on the lathe machine. Okay, next operation is that is thread cutting operation. What I mean by thread. Thread means the helical grooves. You can see here the helical grooves will be formed on the cylindrical surface of the workpiece material. We can call it as the thread cutting operation. We can make the threads. Okay, just we are making the conical shape on the cylindrical workpiece material. That operation we can call it as the thread cutting operation. How you performing the thread cutting operation? During thread cutting operation, initially the workpiece is held between the two centers. One is the dive center and the one is the dead center. Okay. While during thread cutting, first we have to select the cutting tool. Required thread profile cutting tool should be selected first. Either you can produce the V threads on the cylindrical workpiece material, or we can produce the rectangular threads on the workpiece material. First you have to select it. Okay, first you have to select the required thread profile cutting tool, and then you have to select the required pitch, how much depth you have to make the thread. Okay, you have to select the required pitch in the lathe, and then you have to feed the cutting tool against the workpiece material and move parallel to the lathe axis. Okay, so first you have to select the required thread profile cutting tool and then select the pitch and then feed the cutting tool against the workpiece material. Okay, by using the automatic arrangement. Okay, so due to number of passes, the required threads will be formed on the workpiece material. Okay, so with the help of the lead screw, the carriage will be moved automatically. Due to the automatic movement of the carriage, due to number of passes, the required threads will be formed on the workpiece material. That operation we can call it as the thread cutting operation. Okay, just thread cutting means you have to make the conical shape on the cylindrical workpiece material. We can call it as the thread cutting operation. This operation, first you have to select the required thread profile cutting tool, either V thread or square thread. You can select the required cutting tool, and then you have to select the pitch, and then you have to feed the cutting tool by the automatic arrangement of the carriage and move parallel to the lathe axis. Due to number of passes, the required threads will be formed on the cylindrical workpiece. That operation we can call it as the thread cutting operation. Next operation is there is the lathe drilling. Okay, so all of you know the drilling operation. Drilling means making a cylindrical hole on the solid workpiece material by using a drill bit. We can call it as the drilling. Okay, drilling is a machining operation used to produce the conical or cylindrical hole on the solid workpiece material. That operation we can call it as the drilling operation. How to perform the drilling in the lathe machine? Okay, here the one end of the workpiece material will be rigidly held on the chuck or the live center, and another one will be free, and you have to select the drill bit, and this drill bit is rigidly held in the dead center of the tile stock. Okay, you have to feed the drill bit against the rotating workpiece material by moving the tile stock. Okay, here the cutting tool will be held on the dead center. Okay, and the workpiece will be rigidly held on the live center. Okay, we have to feed the workpiece against the rotating workpiece material. Okay, by moving the tile stock. Okay, the sharp cutting edge of the cutting tool. Okay, here in the drill bit there is a sharp cutting edge will be there. The sharp cutting edge of the tool will remove the material from the workpiece. So the excess metal will be removed in the form of fine chips, and that material will be escaped through the conical grooves is provided on the drill bit. Okay, whatever the metal is removed, because the machining takes place inside the workpiece material, so whatever the metal will be removed, that will be escaped through the grooves provided on the cutting tool. Okay, hence the cylindrical hole will be formed on the workpiece. That operation we can call it as the lathe drilling operation. Here the drill bit will be held in the tile stock. Okay, by moving the tile stock we can feed the drill bit against the rotating workpiece material. Okay, in the normal drilling machine the drill bit is rotating and workpiece will be stationary, but here in the lathe drilling the workpiece will be rotating and the drill bit will be stationary. You have to feed the stationary drill bit against the rotating workpiece material. The sharp cutting edge of the drill bit will remove the excess material from the workpiece, so to get the desired cylindrical hole on the workpiece material. This operation we can call it as the lathe drilling operation. Okay. Okay, some of the operations are performed on the lathes are, one is you can perform turning operation, you can perform facing operation, you can perform the knurling operation, and we can perform thread cutting operation, and we can perform lathe operation. Okay, in the turning we can reduce the diameter, or we can produce a cylindrical surface on the workpiece. In the facing, it is used to produce flat surface at the end of the workpiece, so in order to reduce the length of the workpiece material. In the knurling, we can produce the rough surface on the cylindrical workpiece material by using the knurling tool. In the thread cutting, we can make the conical shape on the helical grooves on the cylindrical workpiece material. That operation we can call it as a thread cutting operation. And lathe drilling, we can make a cylindrical hole on the solid workpiece material by using the twist drill. We can call it as the lathe drilling operation. Okay, next the operation is, that is the taper turning operation. How to perform the taper on the drilling machine? There are several methods of taper turning operations are there. One is the swelling the compound tool rest method. We can produce the taper, or by offsetting the tailstock method. Okay. Next operation performed on the lathe is taper turning operation. What do you mean by taper? Taper means producing a conical shape on a cylindrical workpiece material. We can call it as the taper. Okay, taper is nothing but it is the conical surface can be produced on the conical surface can be produced on the cylindrical workpiece material. That operation we can call it as the taper turning operation. Here the cutting tool can be swiveled, it can be moved at an angle. Okay, now what is the first we have to find out the taper angle. In that taper angle we can be tilt the cutting tool. Okay, it can be rotate the cutting tool to the required taper angle and then move parallel to the lathe axis. The cutting tool can be parallel to the lathe axis. At that time the required taper will be formed on the workpiece material. That operation we can call it as the taper turning operation. Before taper turning operation, first you have to find out the taper angle. Okay, so in order to find out the taper angle, we are using one formula, that is alpha is equal to tan inverse of D minus capital D minus small d divided by 2L. That is the formula for calculating the taper angle. Okay, so capital D is nothing but the larger diameter of the taper. Okay, this is the larger diameter, that is capital D, minus the smaller diameter of the taper divided by 2 into L, that is the length of the taper. So we will get the half taper angle, that is alpha we will get. Okay, so whatever the angle you will get, in that angle you can tilt the cutting tool, and then you have to feed the cutting tool and move parallel to the lathe axis. At that time that required taper will be formed on the workpiece. That operation we can call it as taper turning operation. This taper turning operation is carried out by two methods. One is by swelling the compound tool rest method. Another one method is offsetting the tailstock method. Okay, now let us discuss one by one. First, the taper turning operation is the swelling the compound tool rest method. Okay, in the swelling compound tool rest method, the workpiece will be held between the two centers. One is the live center, another one is the dead center, and then we have to find out the required taper angle. For example, alpha you will get 10 degree. Okay, just you have to rotate the compound tool rest. That means having a circular base in the compound tool rest, and in that base they are provided with the graduation in degree. Okay, here there is 0 degree, 10 degree, 0, 10, 20. Okay, there is a circular base. In that circular base the graduation in degree will be provided. Okay, first you have to find out the required taper angle. In that taper angle, just you have to rotate that compound tool rest. Just you can swelling the compound tool rest to the required taper angle. For example, if you get a 10 degree, that is the taper angle, just you have to rotate to the compound tool rest to the 10 degree. Okay, just you have to rotate the circular base to the 10 degree. Okay, and this will support the cutting tool. It carries the cutting tool. First you have to feed the cutting tool against the rotating workpiece material, and then you have to move to the move parallel to the lathe axis. At that time the required taper will be formed on the workpiece. That method we can call it as the swelling the compound tool rest method. Swelling in a sense, it is a rotating the compound tool rest to the required taper angle. First you have to find out the taper angle by using the formula, that is alpha is equal to tan inverse of D minus D divided by 2L, bigger diameter of the taper minus the smaller diameter of the taper divided by 2 into length of the taper. So alpha is equal to, that is the half taper angle. Okay, that is the half taper angle. Okay, so first you have to find out the taper angle, and that taper angle you have to rotate the compound tool rest Okay, this you have to rotating the compound tool test to the required taper angle, and then you have to feed the cutting tool against the rotating workpiece material and then move parallel to the lathe axis. At that time, the required excess metal will be removed in the form of fine chips and required taper will be formed on the cylindrical workpiece material. That means the conical surface will be generated on the cylindrical workpiece material. That operation we can call it as the taper turning operation. Next method of taper turning is the offsetting the tailstock method. Okay, in the offsetting the tailstock method, in normally in the lathe in the normal operations, the live center and dead center will be lies in the same axis. Okay, it is perfectly aligned with each other. But here in the offsetting the tailstock method, the tailstock can be offset to the some amount, that is SMM. Okay, S is nothing but it is the set over. Okay, so first you have to find out the how much alignment will be provided to the tailstock. Okay, that is find out by using the formula D minus D divided into capital L divided by 2L. Okay, D is the bigger diameter of the taper and small d is the smaller diameter of the taper and capital L is the total length of the workpiece. Okay, here we are considering the total length of the workpiece material. Okay, so D minus D into total length of the workpiece divided by 2 into length of the taper. So we will get the set over, that is yes, we will get around 5 mm or 10 mm. Okay, in that amount it will be tilted by the screw provided at the bottom of the tailstock. Okay, just you have to tilt the tailstock to the required set over. Okay, required amount of set over by the nut provided at the bottom of the tailstock. Okay, after that just you have to feed the cutting tool against the rotating workpiece material and move parallel to the lathe axis. At that time the required taper will be formed on the workpiece. So that method is the offsetting the tailstock method. Just you have to offset the tailstock to the required set over. Okay, just you are shifting. First you have to find out the offset, how much offset you have to Okay, while doing the offsetting the tailstock method, first you have to set over, first you have to find out the how much set over. Okay, that means by using the formula S is equal to D minus D into L divided by 2L, bigger diameter minus smaller diameter into total length of the workpiece you have to be considered and divided by 2 into length of the taper. Okay, first you have to find out the required set over. Okay, and then the cutting tool can be set, the drill bit the tailstock can be set over to the required mm by offset the tailstock, the tailstock, and then you have to feed the drill bit, or sorry, you have to feed shifted by rotating the. Okay, while doing the set over, first the tailstock can be shifted to the required mm, that is around 5 mm or 10 mm. Okay, that will be calculated by using the formula. Okay, that will be provided, the set over screw will be provided at the bottom of the tailstock, that can be set over, and then you have to feed the cutting tool against the rotating workpiece material and move parallel to the lathe axis. At that time the required taper will be formed on the workpiece material. That operation you can call it as the taper turning operation by set over or offsetting the tailstock method. Okay, these two methods are used for producing the conical surface on the cylindrical workpiece material. Okay, that operation we can call it as the taper turning operation. We can make a taper on the cylindrical workpiece. Okay, that is carried out either by using the swelling the compound tool rest method or by using the offsetting the tailstock method. Okay, so these are all the operations can be performed on the lathe. Okay, you can perform turning operation, we can perform facing operation, we can perform a thread cutting operation, we can perform lathe drilling, we can perform turning operation, we can perform knurling operation. Okay, and we can perform taper turning operation. Okay, almost all the basic operations can be performed on the lathe machine. Okay, Thank you.